Sharp 3 p.m. in India. Let's respect time. Let's start. First of all, please confirm if I am audible, if my voice is clear. Doesn't matter where you are watching. Maybe you are watching me on Facebook. Maybe you are watching me on YouTube. Maybe you are directly connected here in the Google meeting. I'm able to see you all guys here, even your comments. Let me open the chat as well. Yes. When will class start? Yes, class is starting soon, within 5 minutes. First of all, please confirm me if I am audible, if my voice is clear and crystal, and is my screen is visible. Just type yes in the chat. If you are watching me on YouTube, just type yes in the comment section. If you are watching me Facebook, LinkedIn, just type yes in the comment section. Here also in the Google Meet. So many people are saying yes. That means I am audible. Thank you so much for joining and for the confirmation. Guys, few questions are coming in my mind. Let me settle these questions first so that I can focus on the content. Mainly here I am today to discuss the very important protocol, that is MP-BGP, right? In the production network, everywhere you will see this protocol. On the customer router, like if you are working in enterprises side, enterprise in the production side, maybe you will be configuring C router. So that's also important for you. How to configure C router. Doesn't matter P router or C router. And today, if you are going to attend me till the last, then I am damn sure you will never forget this MP-BGP in your entire life. Right? Even you don't need to learn it again. Today, I am going to discuss each and every word of this protocol. Right? We have 2 hours. In 2 hours, maybe I will not show you the practical, will not perform the configuration, but definitely you will be able to configure by yourself. We'll discuss all the commands, configuration, logic, everything. But guys, as I told you, some questions are coming in my mind, and really these questions are bothering me. So until and unless I will not settle these questions, it will be difficult for me to focus on content. So the first question which is coming in my mind is, where are you from? Just I want to know from where people are joining me, from where people are watching me. So just type your city name in the chat. Right? If you are watching me on the YouTube, just type your city name in the chat. Let me see. And after that, directly I will start the session. Lucknow, Pune, okay. So fine. People are joining from multiple places. Great. From multiple country, from multiple cities, and see the power of technology, guys. Through one single click, you can join from anywhere. Thanks to
My
technology. Thanks to technology. Few years back, it was not possible. But nowadays, with a single click, you can become a host, and we all can become a member. Very good. Thank you. Thank you so much. Now, my name is Praful Mishra. Guys, if anyone don't know me, so let me introduce myself. My name is Praful Mishra. I am a network architect by
yes,
my profession and a
your song.
interested technical trainer by my passion. I love to teach people. I love to deliver my technical knowledge and always try to deliver the real time experience. Whatever scenario I am troubleshooting in the companies, right? Same I am sharing with you guys through the YouTube channel. So I have YouTube channel named PM Networking, over 50,000 subscribers, where I am sharing my technical knowledge. And many of you are loving to watch my videos. This is the reason every day why I am uploading videos. A small introduction of myself. This will be disturbing me the entire session. So now, guys, will not allow after 5 minutes to join in the Google Meet, right? So whoever have joined, that's great. You guys can enjoy the session. Chennai, Kanpur. Thank you so much for joining. And now, without wasting time, let's begin. One more thing. Just tell me, is board visible for you? Is board these texts are clear to you? Is these texts are clear? Is board visible
Yes,
for you?
clear.
Great. Thank you so much. Thank you so much. So, guys, what I am expecting, you all know the normal BGP, right? The general BGP. General BGP means Border Gateway Routing Protocol for the IPv4 network. For IPv4 network, you all know the BGP. We have different types of network that is called address family, right? Like IPv4, IPv6. You can understand address family. You can think about address family like types of network: IPv4, IPv6, multicasting, VPN. These are the address family. And the normal BGP, Border Gateway Routing Protocol, can support network only. We can run normal BGP in IPv4 network only. But if I will talk about the MP-BGP, so MP-BGP support multiple address family. MP-BGP supports multiple address family. Multiple address means we can configure MP-BGP for IPv4 networks, also for IPv6 network, also for the VPN also, right? For multiple types of address family, we can run this protocol. And this is also routing protocol only, like your normal BGP. This is also a routing protocol only like your normal BGP, OSPF, for like other routing protocol, ISIS. But this is the advanced. And where we are using it, we are using it generally in the service provider network. So before talking about the MP-BGP, let's understand the service provider network. What is service provider? What is service provider? Guys, there are two types of providers. One is SP and second one is ISP. You know the difference between SP and ISP? If you know the differences, please let me know in the chat. Please type few differences in the chat. What is ISP and what is ISP? What is SP and what is ISP? ISP, Internet Service Provider. Very good. Internet Service Provider means who are going to provide you the internet service. And the SP, yeah, SP is providing connectivity between sites, connectivity between multiple sites. For an example, in a company, there are multiple sites. Like if I will talk about the big company, guys, like Google. So Google can have more than 1,000 branches around the globe, and their all sites are connected together, not through one service provider, through multiple service provider for the redundancy, for the load balancing. Correct? So let me take one example of a very small company where we have few sites. Few sites means 2 to 3 sites. For an example, company is XYZ. XYZ. So this company, XYZ company, have two sites. One in, let's say, India. This is one side in India, and one another side, let's say, data center headquarter in the US, somewhere in the US headquarter. Now, this company, XYZ company, need to connect their branch office to data center or to headquarter. Someone is waiting. Let me allow him. Yeah, this company want to connect these two sites together, because reason is maybe this company resources are located at here in the DC, in the headquarter. Maybe there are some resources means like their application, their website, their Gmail server, their file servers. So these resources are located here in the DC. And lots of employees are sitting here in the branch one. And these employees need to access these resources. And nowadays, we are hosting our resources on cloud as well, right? So these services can be hosted on our own server, that is called on premises, or we can host it on the cloud. Doesn't matter where we are hosting, but at the end, we need what? Connectivity. Means my all sites should be able to communicate with each other. So how we can connect? Is it possible to place our own cable between India and US? No, 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 never. Not possible. Even government will not allow you to place your own cable. Apart from that, it is going to be very complicated, very costly process. So the another company have already link between India to US, right? Like inside the sea, there are submarine cable. Through submarine cable, all the cities are, like, all the countries are connected together. All the countries are connected together. That is called tier one ISP or SP, you can say. Tier one ISP who are connecting multiple countries together with the help of submarine cable. And within the countries, ISP to tier 2 ISP are connecting cities together, right? So they guys have already cables. They guys have already cables between country, between the cities, between countries and between the cities. So what service providers is saying here, just do one thing, just take my link between India to US on rent. You need to pay some amount on the monthly basis, and I will be responsible for the connectivity. Even I will guarantee, I will give you security for the 100% availability. Like my link will be 100% available. 24 by 7 link is going to be available, or 90% type time link will be available. For the backup, you can take another connectivity as well. So how service provider are going to provide connectivity? So what I told you guys, service provider have already link, right? Between India and US, again, there are multiple workstation of service provider, and their all workstations are connected together. They are all workstations are directly connected together. So that means the service provider have connectivity between India and US. Now we need to place one router here and we need to connect it to service provider router. Here also we need to place one cable and we need to connect it to service provider network. After that, between this router and this router, we can create one logical network. Logical, that is virtual network, that is called tunneling technology, VPN technology. That is called VPN technology. The reason is service provider is public, right? This is not your network. Multiple companies like you are using their network, right? So between private and public communication is not possible, or you can say between two private network or public network communication is not possible, right? So the technology which we are using to make it possible is VPN. The technology which we are using to make it possible means to make communication possible between different Private network over public network is called VPN. Always keep in mind, by default, two private sites cannot communicate through public network. Public network can be like internet or multiple transportation are there, MPLS, metro ethernet, LTE, 4G, 5G. These are the transportation public service which is available for everyone. Anyone can purchase connectivity from them, can purchase their bandwidth, they can use, utilize it, and they have to pay the rent, right? In the same way, you can also open your company, you can also place cable in the village where, let's say, the good fiber cable is not available. There you can open ISP company and you can place the cable, and after that you can start providing connectivity between multiple points. So here service provider is providing connectivity between two sites. Like this, I can have multiple sites as well. Now I am going to combine these all workstation together. For an example, here is the service provider. This is service provider. Now, in the service provider network, there are lots of routers. You know, it is connecting, it is covering large geographical area. Definitely, lots of networking devices will be there. Lots of routers will be there. And then here is the customer. Right? This is, let's say, customer one, customer A. This is a customer A. So this customer need connectivity. Customer A, this is, let's say, side one. Customer A, side one. And in the same way, this customer have one another side at different location. Customer A, side 2. Right? So this customer need connectivity between side 1 and side 2. They can purchase connectivity from service provider. Service provider is going to connect their network like this. Like this. Now these two sides of customer A are connected together. With the help of VPN, we can make reachability. Side 1 and side 2 can communicate with each other. Now guys, in the same way, there will be another company as well. Let's say there is one another company, customer B, customer B side 1. And here is the another side of customer B, customer B side 2. Side 2. This customer also need connectivity between these two sides. They can purchase connectivity from service provider. Now question is, first thing is, how service provider is going to differentiate these two customer? How service provider is going to differentiate these two service provider? As you know, there are two types of IPv4 address. We divide IPv4 address into two parts. Guys, first of all, we have 32 bits IP address, but the requirement of IP address is huge. As compared to requirement, we have very less number of IPv4 address. That's why first we divide IPv4 address into classes, then we come up with subnetting, then we divide again into private and public, so that private IP address can be reusable. Multiple companies can use same private IP address. Correct? Now, let's suppose both companies using same network 10.1.1.0/24. This company is also using 10.1.1.0/24 in side 1. Customer B, side 2 subnet is 10.1.2.0/24. And here again 10.1.2.0/24. So you can see both customers are using same subnet. How service provider is going to differentiate it? How service provider is going to differentiate? This is the first question. Second question, like this location is and this location, that these 2 points are at different location. Maybe there are huge distance, 1000 kilometer, 5000 kilometer, right? Or 100 kilometer between this router to this router. So how service provider is going to forward this network from one point to another point? The reason why I am saying this is, just keep in mind one thing, that in service provider network, guys, there will be lots of routers. Let's say there are 5000 routers. 5000 routers are there in the service provider network. So like this customer A and customer B, right now we have only 4 sites, right? If each site is going to advertise 10 number of prefixes, so total number of prefixes are 40. 40 prefixes are there total customer prefixes. These are not the prefixes of service provider. Service provider will have their own networks inside their network, but customer are advertising 40 subnet. This is very basic requirement of a very small companies. Generally in one company, you will have 10 to 15 sites. 10 to 15. Just take an example of Amazon. Amazon will have more than 10,000 branches across the globe, and at each branch they will be using lots of networking devices, routers. They will be advertising lots of prefixes, right? So like this, if service provider is connecting 1000 customer together, 1000 customer together. So all 1000 customer have 2 sites, minimum 2 sites. I'm taking just example of 2 sites. So if 2 sites are there, but minimum what I told you, 10 site minimum. So 10,000 sites will be there. 10,000 sites. If there are only 2 sites, then also 2,000 sites are there. 2000 sites are connected with service provider network, and each site is advertising how many prefixes. For example, only 10 number of prefixes, only 10 number of prefixes. So 10 multiply by 2000, 1 2000, right? You can see the huge number. Now, is it possible to carry these all prefixes in the routing table of all router in the service provider network? Guys, service provider have to purchase high configuration router, lots of high configuration routers with very good memory, which can store lakhs of prefixes in their routing table, which can carry lakhs of prefixes in their routing table. What I told you, you can also open the service provider company. You can be ISP too. So, are you going to invest this amount of money? No, no. So, the logic is we have to do something here so that we will not store all the prefixes in the routing table of all the routers in the service provider network. Then we come up with MP-BGP. Then we come up with MP-BGP. Now see the reason why. What I told you here, total 2000 prefixes, come each site is advertising 10 number of prefixes. So around 20,000 prefixes are there. So routers inside the service provider network, routers inside the service provider networks are not able to store 20,000 of prefixes in their routing table. There are some normal configuration routers. Now I am going to do one thing. I am going to remove this diagram and I'm going to expand this network of service provider. Let me expand it. See, for an example, this is service provider network, right? Where I have lots of routers like this. And all the routers are connected together this way. Right? So these are the edge routers. You can see this is maybe not edge router, but this is edge router. Here I can connect customer. Here I can connect customer. On any router, I can connect customer, and then customer are going to advertise prefixes. Right? So the edge router of service provider network is called P router, and inside the service provider, whatever routers are there, those routers are called P router. Right? So service provider need to purchase only high configuration router for edge devices. Like P routers are going to be high configuration. P routers are going to be high configuration. Now, for an example, this router is connecting one customer A, side 1. Side 1. So customer A side 1 is going to advertise prefixes to this router, and we want a technology through which we can directly advertise it to other side, right? So let's suppose same customer is connecting side 2 over here of same customer A, side 2. Fine. So customer A and customer B need to exchange prefixes with each other. But service provider routers like these routers are normal configuration router. These routers cannot store lakhs of prefixes in their routing table. So we need something, some technology through which service like the customers are going to advertise prefixes to the service provider router, and this service provider router will directly advertise those prefixes to this service provider router to other side of PE, right? And then PE will advertise to this router. Means these routers should not install all the prefixes, all the customer prefixes in the routing table, right? These routers should not install all the prefixes in the routing table. The benefit is now here these routers can be the normal configuration router with normal memory, normal process, and these as this router is going to install customer A prefixes and then it is going to advertise to other customer. Maybe here we need good memory, because like this maybe this router is connecting more customer as well, right? So see, there are two types of router in the service provider network. One is PE router, PE router, and second one is P router. PE router stands for provider edge router, and P router is provider router, provider router, right? So provider router is going to be normal router which will not install the routes of customer in their routing table, right? See, there are few things that you need to keep in mind here. One, again, this is service provider, and I am going to make this topology bit simple. Here I have one router. This is PE router, PE provider edge router. Here I have another router, normal router, P router. Again, I have one P router, and this is again PE router, PE, right? So PE is provider edge, means who is connecting customer sites. Let's say here now I have customer A, side 1, another customer B, side 1. Here customer A, what happened? Just a minute. What happened? 1 सेकेंड गाइस, थोड़ा सा लाइट का इशू हो गया. 1 सेकेंड, इन्वर्टर पे शिफ्ट हुआ है. 1 minute. So I need one IPS here, no problem. Till then, if anyone have any question, please ask in the comment section. Just it will take 1 minute. Whenever it's shifting to the inverter, it's fluctuating with dedicated cable. If anyone have any question, please ask. Many people are here in the Google Meet, the YouTube live. Okay. Yeah, I am coming to this point. Don't worry. Yeah, VRF as well. Will come on VRF. VRF is the core concept of MP-BGP. VRF is the core concept of MP-BGP. Again, I am expecting my screen is visible. Right? So here was the company. No, this one was the not topology. P and normal P router was there, and then again one P router was there, right? And then two customer A side 1 customer B side 1, then customer A side 2, and customer B side 2. Now, see, what is the logic, guys? What I told you, that customer are going to advertise prefixes to service provider, means to P router. Why I'm saying P router? Because this router is connecting service provider. So this is edge router of service provider, PE, provider edge, right? So this router, customer router, is going to advertise prefixes to P router, provider P router, provider edge router, and provider edge router is going to advertise it to other provider edge router directly, other provider edge router directly to this router, and then this router will advertise it to side 2 of customer A. Two things: first, how to differentiate customer A and customer B. Customer A and customer B, this provider edge router is connecting two customer, and both customer are using same subnet 10.1.1.0/24, 10.1.1.0/24. How to differentiate these two prefixes on service provider router? So guys, see, the global routing table. What is global routing table? The global routing table means by default all the interfaces of router belongs to a single routing table, that is called global routing table. For an example, I have one router. This is my router, and on this router there are some module. In the module I have added the card, then power supply is there, right? So some ports are there: 0/0, 0/1, 1/0, 1/1, 2/0/1, and I am connecting multiple network through this router, right? Let's say this interface is connected to internet, this interface is connected to LAN. LAN, this interface is connected to WAN, right? And some interfaces are connected to, let's say, one server room or the another small departments. So all the interfaces are member of global routing table. Router is going to maintain one routing table, one routing table, and all the net interfaces, all these interfaces are part of that routing table, right? Means router is going to install this network also in this routing table, this network also in this routing table. Means all the interfaces are part of single routing table, like VLAN. Guys, by default all the ports of switch belongs to single VLAN, right? That is VLAN 1. So that's why we are saying by default we have only one broadcast domain on switch. But if you want multiple broadcast domain, what you can do, you can create multiple VLAN there. We can put some interfaces in different VLAN, some interfaces in different VLAN. So with the help of VLAN, we are dividing the broadcast domain. So in the same way here, we need to divide the routing table of this router, right? On this router also, on P router, I need to divide this and this. I need to create two routing table. By default, router have only one routing table, and this interface, both interface are member of that global routing table. But if I will divide the routing table virtually, then definitely router can understand it. Then router can differentiate the customers. Now router will have two routing table, one for customer A, one for customer B. Means one for this interface, one for this interface, one for this interface, and one for this interface. So dividing router virtually is called VRF. What is VRF? What is VRF? VRF stands for virtual router forwarding. Virtual router forwarding means dividing router virtually, routing table of router virtually. For an example, I have router 1, R1, and there are two interface. One is F0/0 and one is F0/1. Guys, here let's say my IP address is 10.1.1.1/24. And here if I will try to configure 10.1.1.1/24 again, is it possible? Or 10.2, can I configure 10.2 here? No. 10.2, no. Reason, once I will hit this command on this interface, it will give me the error that this IP address is overlapping, that this IP address is overlapping with 0/0, right? This IP address is overlapping with 0/0. The reason is both interfaces part of single routing table, that is global routing table. But if I will divide this router into two parts, then yes, then we can configure same IP address, same network on multiple interface, because now router will have two routing table, one for this interface and one for this interface, right? Here it is separating both the interface with the help of multiple routing table, and this particular thing is called VRF means dividing the routing table of router virtually, right? So there are now two routing tables. So how we'll do that? On the router, simply we can run command route VRF and then name VRF, let's say A, for the customer A. Once I will hit this command, router is going to start maintaining a table for VRF A, routing table for VRF A. Once I will run VRF B command, router is going to start maintaining a table called VRF B. Now, when I will assign this interface, when I will put F0/0 in VRF A, it is going to store this network in this table, and once I will put this interface in VRF B, router is going to install this interface over here in this routing table. So now router have two routing table virtually. Actually, now router have three routing table. One global routing table, which are the interfaces which are those interfaces which are not member of any VRF, right? So those are still part of global routing table. And the one is VRF A routing table, one is VRF B routing table. So we have total three number of routing table on the router now. Okay. So same technology we need to use here in the service provider network, guys. PE and then normal router, P router, and again PE router. Right? If this time it is connecting to customer, no problem, we can differentiate it with the help of VRF. Here we can create VRF A, here we can create VRF B, right? So now two VRFs are there on this router, means two routing tables are there. Over here as well, we can create VRF A and VRF B. Now question is, Praful, tell me one thing. Now question is, Praful, tell me one thing. If this P router is going to advertise any prefixes to this P router, let's say this is P1, this is P2. How P2 router will get to know about the VRF, that this prefix belongs to which VRF? For an example, here the subnet is 10 dot, what happened? Here prefix is 10.1.1.0/24. So this router, my edge router, customer edge router, is called CE router. CE means customer edge, right? And between customer edge to provider edge, I can run any routing protocol to advertise prefixes. Let's say here I am running OSPF routing protocol, right? So through OSPF, this CE router is going to advertise this to P router. Now P router is going to advertise it to other P router, this router, right? It will not, this router is not going to install prefixes in their routing table. Fine. Question is, how this router will understand that this prefix belongs to customer A or this prefix belongs to customer B? For customer A, we have what? VRF A. For customer B, we have what? VRF B. Correct? So how this router will get to know about the VRF ID? So for that, we have something called RT. Before that, before talking about the RT, we have to understand RD, route distinguisher. What is route distinguisher? Guys, in the service provider network, as you can see, this P router is connecting to customer side, and both customers are using same prefix, same IPv4 subnet, right? So first of all, on this P router, we have to make these two prefixes unique, right? We have to make these two prefixes unique. For that, we are using what? RD value, route distinguisher, which is going to differentiate the IPv4 prefixes. which is going to differentiate the IPv4 prefixes. For an example, for VRFA, actually RD is nothing but the 64 bits value, decimal value. So here for VRFA, I am going to add 1:1 is my RD. RD. Rod distinguisher for VRFA is 1:1, and rod distinguisher for VRFB is 2:2. Now, what will happen whenever this P router will receive any prefixes on this interface, which is member of VRFA? Whenever router will receive any prefixes on this interface, which is member of VRFA, it will add this RD value with prefix. In the same way, when router will receive any prefixes over this interface, so this time receiving interface is part of VRFB, so it is going to add this RD value. This RD value. Now, customer is advertising this IP network. This is 32 bits prefix. 32 bits information. When P router will receive this 32 bits prefix, it is going to add what? RD means 64 bits extra information. Then my prefix over here is going to be for VRFA. For VRF, for VRF A, my prefix is going to be 1:1 ratio 10.1.1.0/24. And for VRFB, customer B prefixes, it is going to add this route distinguisher value 2:2, then 10.1.1.0/24. Now you tell me this prefix belongs to customer A and this prefix belongs to customer B. Both are same or different, guys? Both are different. Both are different because of route distinguisher value. Both are different prefixes. And the total length of this prefix is 64 bits. 64 bits. 32 bits IPv4 prefix which customer have advertised, and 64 bits route distinguisher value, RD value. So total length is 64. Here also 64. And you know, the normal BGP or whatever protocol you know, the IGP protocol or EGP protocol, EIGRP, OSPF, RIP, ISIS, these all routing protocol can advertise 32 bits prefixes. These protocols cannot advertise 64 bits prefixes. These 64 bit prefixes are called VPN v4 prefix. VPN v4 prefix. Right? These prefixes are called VPN v4 prefix. VPN v4 prefix means IPv4 subnet plus RD value, route distinguisher value. Right? So to advertise VPN v4 prefix, we are using what? MP-BGP. What we are using? MP-BGP. Like your normal BGP is advertising 32 bits prefixes, MP-BGP advertise VPN v4 prefixes whose length is 96 bits. Right? So if someone will ask you what is MP-BGP, your answer should be MP-BGP is used to advertise or exchange VPN v4 prefixes. Second question, what is VPN v4 prefixes? VPN v4 prefix is IPv4 prefix plus RD value, route distinguisher value. Third question, why we are using route distinguisher value? To differentiate the prefixes of customer in service provider network, because multiple customers can use same network. So doesn't matter what network customers are using. That's really not matter for me. For the service provider, they have already created one VRF for one customer. They know customer A with their VRF. That's it. They only know their customer with VRF. VRF A means customer A. VRF B means customer B. And whatever prefixes it will receive from customer A, that means receiving interface is part of VRF A. It is going to add this route distinguisher value. So in the service provider network, all the subnets of customer are unique. Yes or no? You can see? Yes. All the prefixes of customer are unique in the service provider network. In the same way, whenever whatever prefixes it is receiving from customer B, it will add this route distinguisher value 2 ratio 2, which is going to make the prefix unique. And after adding route distinguisher value, RD value with prefixes, what we call that VPN v4 prefix. And to advertise, to exchange VPN v4 prefixes between two routers, we have only one routing protocol that is called MP-BGP. Right? So where we will configure MP-BGP? We'll configure MP-BGP between PE to PE, PE1 to PE2. Right? So here we'll have MP-BGP neighborship. So router is going to advertise all prefixes to their neighbor. Second question, how this router will understand which prefix I need to import or export in VRF A, and what prefixes I need to import or export in VRF B. Right? So guys, tell me the answer. What is the solution? Now question is, when, let's suppose this P router, P1 router have received this prefix from customer here, and it have add the RD value, which is 1 ratio 1, and this is the VPN v4 prefix. Now P router have advertised it to this P router, P2 router. Now how P2 router will get to know to whom I need to advertise, to this side or this side? Tell me in the comment section, let me check. Tell me what is the solution now. Tell me the solution. What is the solution? What is the solution? Now solution is second component that is called, let me check here if someone is typing. Nothing is there. Okay. Now the second component is called RT, route target value. Route target value. So guys, manually we can tell to VRF A on P1 router that, brother, whenever you are going to advertise any prefixes in VRF A, please add route target value 100 ratio 100 or 10 ratio 10. Let's say 10 ratio 10. What is happening? 10 ratio 10 for VRF A, and for VRF B 20 ratio 20. So now what will happen when P router is going to advertise this VPN v4 prefix to another P router? VPN v4 prefix means IPv4 prefix plus RD, right? And we have said to add this one also, like export. What will say to VRFA? Export this RT value, route target value, with VPN v4 prefix of VRFA. So now it is going to add VPN v4 prefix plus 100 ratio 100. And now on this P router, I have again two VRF and VRFB. I can tell to this router that, brother, whenever you will receive any prefix with RT value 10 ratio 10, just import that or export that in VRFA. Export that in VRFA. So router, this P router is going to advertise it in this site. And this way, these two sites are going to exchange the route. If still it is not clear to you, just give me some time. I am giving you the detailed configuration with example. Let me check the PDF, and someone is waiting in the queue. So let me allow him first. Till then, if anyone have any question from this, please let me know in the comment section. If you are connected on Google Meet and you have question, please type there in the chat. If you are watching me on YouTube and if you have question, please put your question in the comment section. Same for Facebook, same for LinkedIn. This is a great setup, guys. I never thought that one day I can, go live on multiple platforms once. Now I am live on multiple platforms. The great setup. Really love it. Any question? So far, good. I'm not selling, brother, anything. One guy is asking, sir, what are you going to sell today? So today I'm not going to sell anything, brother. Today's session is just for knowledge sharing. Just want to understand the configuration. Good, good, good. Definitely. Okay. So hope it is clear. I'm not receiving any question. Everyone is saying it's clear. Can we configure BGP without network command? Yes, you can configure BGP without network command. Where is the network command? Network command is not required to configure BGP. Here will not configure network command. What will do, guys? Let's suppose between this P to C, I'm running OSPF routing protocol, right? And here I have BGP. So I can directly redistribute OSPF into BGP. Once I will redistribute OSPF into BGP, it will install that prefix in BGP table, then it will advertise to other P router. And here, let's suppose here I am running EIGRP between customer A side 2 and P router EIGRP. So here now we need to redistribute BGP into EIGRP. Automatically it will advertise to site 2. Only redistributions are required here. Let me show you the PDF also. Hmm. Okay, so here you can see about the network. So for an example, this is a design network architect of a company where same way I have two side, customer A side 1, customer A side 2. Let me reduce the pin size. Yeah, customer A side 1, customer A side 2, customer B side 1, customer B side 2, and both customer are using, you can see, same subnet 10.1.1.0/24, 10.1.1.0/24. Here 10.1.2.0/24, here 10.1.2.0/24. Now between PE to CE, this is my PE router, PE, P1, this is P2. This is CE router, CE. This is also CE router. This is also CE router, customer is router. This is also CE router, customer is router. Right? Between P to C, I can use any IGP protocol. I can use any IGP protocol here. Let's say I am running OSPF. Here I am running EIGRP. Here I am running again RIP routing protocol. Here I am running EIGRP as number 100 and here EIGRP as number 200. EIGRP 200. So all the customers are going to advertise prefixes to service provider with the help of IGP protocol, either by using OSPF, EIGRP, RIP. Right? These are the IGP protocol. You know how to configure it and how these protocols work. Second thing, now service provider. In the service provider, guys, what we can do between P to PE, between P1 to P2, I can configure MP-BGP. And for the MP-BGP, see, if I have only one path, like here I have only one path. So if we have only one path, then no problem. We can use the physical IP address as well for the BGP neighbor. You know, I need to run command here, router, BGP, AS number, and then neighbor. We need to define the neighbor command. Router BGP AS number 100, and then neighbor. So if I am saying neighbor IP is, let's say between router 2 and router 3, my subnet is 23/8, and between router 1 and router 2, 12/8, 12.1.1.0/8, or 12.0.0.0/8. So neighbor 23.0.0.3, and I can say remote AS 100. That is fine to configure the BGP, but if R2 will goes down, then my BGP neighborship will goes down. Yes or no? Yes. Then BGP neighborship will goes down. So guys, here in the real time, you will have lots of path between PE to PE. Between PE to PE, you will have lots of path. So in this scenario, when we have multiple path between PE1 to PE2, what we can do, we can form BGP neighborship with the help of loopback interface. Because let's say here I have created one loopback 1.1.1.1. Here I have created loopback 3.3.3.3. So if 1.1.1 and 3.3.3 are reachable with each other, then we can form BGP neighborship between these two loopback with the help of these two loopback. And guys, if any link is up, until and unless any link is up between this P to this P, my BGP neighborship will be up. So the correct way to configure MP-BGP over here is this, by with the help of loopback. With the help of loopback here, one dot, sorry. Here 1.1.1.1, here 3.3.3.3. Right now on router number 1, I'm going to run command router BGP ES number 100 for an example, and then neighbor 3.3.3.3, and remote ES is, let's say, 200. For iBGP, if you want to configure eBGP, you can configure. For iBGP, you can configure it both. So here you can see my ES number is 100, remote ES is 200. That means eBGP. If you want to configure iBGP, you can configure iBGP as well, remote ES 100. Then I have to add one more command here, neighbor 3.3.3 update source loopback 1. Then guys, this command is going to form BGP neighborship for IPv4, not for VPN v4. This command will form BGP neighborship for IPv4, not VPN v4. So how to form neighborship for VPN v4? For VPN v4, we have to activate the neighbor. By default, neighbor is deactivated for VPN v4. What happened here? Erase option is not there, not available. Okay, 1.1.1.1, sorry, 3.3.3.3. Only clear option is there. How it's possible? I have to talk to team 1.1.1.1 and 3.3.3.3. So first you will define the neighbor command, and after that you have to activate it for VPN v4. So the additional command which you need to run on router number 1 is router BGP ES number 100, and then address family VPN v4, and then neighbor 3.3.3.3 activate. So these commands are required on R1 also and R3 also. After that, you will have MP-BGP neighborship between 1.1.1 and 3.3.3. You will have BGP neighborship here. BGP neighborship. Now question is, Praful, how 1.1.1 and 3.3.3 are reachable with each other? So for internal reachability, we can use any IGP protocol here. Let's say OSPF. OSPF is IGP protocol inside the service provider network for the internal reachability, right? And definitely you will be using OSPF only in most of the scenario. In 90% cases, we are using OSPF protocol as a IGP protocol. So through OSPF 1.1.1 and 3.3.3 will be reachable. Means this router, P router, all the P routers in the service provider networks are only going to store internal prefixes, right? Like router 2 will have route for 1.1.1 and 3.3.3, right? Like this will have 1,000 number of routers, and those all 1,000 number of routers will have routes for these loopback. That's it. Will not have routes of customer here. Correct? Clear? So this command is going to activate the neighborship, and after that we'll have MP-BGP neighborship. Then we can advertise the prefixes. So see, in service provider network, first of all, IGP protocol is required, then MP-BGP protocol is required. After that, after that redistribution. Here, as I told you, if I am running OSPF, so we need to redistribute OSPF into BGP. So router BGP AS number 100, then again address family, I address family VPN v4, and then redistribute OSPF, OSPF, right? Here you will run command like this in OSPF. Now we need to redistribute BGP into OSPF also, so that one side 2 will advertise prefixes to customer A, customer A will advertise to provider A, provider A will advertise it to another side provider A, and this provider A will advertise it to side 1. So here we need to redistribute BGP into OSPF as well. OSPF into BGP, and then BGP into OSPF. Correct? So now the next command can be router OSPF, then address family IPv4 unicast VRF. For which VRF? VRF A. So this command, router OSPF IPv4 unicast VRF A, is going to enable OSPF for VRF A only, right? And after that we can say redistribute BGP protocol. So this way we can redistribute, okay? And after that this P router will advertise side 2 prefix to side 1 and side 1 prefix to side 2. So on both P router we need to perform redistribution. For redistribution, 1 OSPF into BGP, BGP into OSPF, and here if I'm running EIGRP, so EIGRP into OSPF, sorry, BGP, and then BGP into EIGRP. So these redistribution, these all redistributions are required on this router as well as on R3, another P router. And like this, guys, we will have multiple customers, right? And we'll have lots of P router. Here also I have one P router who is connecting one customer. Here also I have one P router who is connecting customer. Here also P router connecting customer. Here also, right? And all these service providers router are connected together like this, right? So what we can do, on all the P router we can create loopback, right? Like here loopback 1.1.1.1, here loopback 3.3.3.3, here loopback is, let's say, 5.5.5.5, here loopback is 6.6.6.6, and this is customer C side 1, customer C side 1, this is customer C side 2. So we can form MP-BGP neighborship between 5.5.5 on 6.6.6. And how 5.5.5 and 6.6.6 are reachable with each other? Through OSPF routing protocol. Through OSPF routing protocol. So this customer will again advertise prefixes to their P router, and their P router will advertise it to other sites, to other P router, and this P router will advertise to this customer router, C router. So this way MP-BGP will work here. Now let me check what else are there. There are some theory part. Let me discuss this also. According to my team, I should cover these all. Yeah. So MP-BGP stands for multi-protocol BGP. So what you can see, you can say MP-BGP is advanced version of BGP. Advanced version of BGP, guys. BGP is used to exchange routes between the autonomous system number. That's why we are saying it is eBGP protocol, EGP. exterior gateway protocol. And MP-BGP is an advanced version, extension of border gateway protocol that support routing protocol for multiple address family. What I told you, same. MP-BGP is used to advertise or exchange prefixes for multiple address family. What is address family? Address family is nothing but the type of network, like IPv4 network, IPv6 network, multicast network, VPN network, this way. Okay, such as IPv4, IPv6, multicast, VPNs, and your normal BGP can advertise or exchange prefixes only IPv4 prefix, not IPv6 or the VPN prefix, multicast prefix. So here we have to use MP-BGP. MP-BGP is the only solution, right? And generally used in the large network, where we are using MP-BGP in large network. And even one more protocols are required, right? See guys, till now we have configured IBGP between P to C and IBGP inside the service provider network for internal reachability. Then we have configured MP-BGP, and after that, as provider routers don't have route in the routing table, as this provider like R2 don't have route in the routing table. So how router 2 is going to process the traffic? Let's say for an example, here I have advertised this network to, see, I have advertised this network to this router. This router is going to install it in the routing table. In the routing table, the 10.1.1.0/24, and next hop IP address will be R4. R4. Correct? In the same way, for this side also, like customer B side 1, there will be one routing table, separate routing table, and there will be route. Then it will advertise to R3. On R3 also we'll have this prefix in routing table, 10.1.1.0/24, and R1 is the next hop. Means if this router R3 will receive any traffic for this network, it will forward to router 1. Then it will advertise to R6. So R6 is also going to install 10.1.1.0/24 in their routing table, and next hop is R3, right? Then this network R6 will advertise it to this P router. This P router is going to install it in their routing table, 10.1.2.0/24, reachable via R6. Then it will advertise to R1. R1 is going to install it in routing table /24. Next hop is R3. Then it will advertise to R4. R4 will finally have 10.1.2.0/24. And next hop is R1. So all the routers have route in the routing table. Now how communication will happen? Let's say PC1 is going to ping this PC6, right? I'm going to ping 10.1.2.1 for an example. Guys, try to understand now. It's very important. Now, PC is going to generate traffic. Source IP 10.1.1.1, destination IP 10.1.2.1. Router will check, it will, PC will forward this to router. Router will check their routing table. In their routing table, you can see route is available, and next hop is router number 1, R1. So R4 is going to forward it to R1, router 1. Router 1 will receive the traffic. It will compare destination IP address with their routing table. It will check the receiving interface is part of which VRF. Receiving interface is part of VRF A. So router 1 is going to look up this routing table, VRF A routing table. In the VRF A routing table, there is one route, this one, 10.1.2.0. Destination IP is 10.1.2.1. This IP address will match in this entry. Router 1 is going to forward it to router 3. Next hop will be 3.3.3.3 for this prefix. So router 1 will forward to 3.3.3. But can router 1 directly forward this traffic to 3.3.3.3? No. Router 1 have to forward it to router 2. So router 1 will check to forward traffic to 3.3.3.3, what is exit interface, right? Then router 1 will get to know, router 1 is going to check the route for 3.3.3 in the global routing table, it will find, right? And it will find this interface as exit interface. So it will forward traffic to router number 2, right? Router will look up the routing table twice. First, to compare the destination in VRF routing table. Then it will came to know about next hop IP address, which is 3.3.3.3. Like 3.3.3 is advertising this subnet. Now to forward traffic to 3.3.3.3, what is next exit interface? Fast Ethernet 0/0. It will forward to router 2. When router 2 will receive the traffic, router 2 is going to compare destination IP address with routing table, but route is not available in the routing table of router 2 for this IP destination 10.1.2.1, right? Router 2 is not installing these prefixes in the routing table, so router 2 will discard it, right? So even after configuring these all IGP, MP-BGP, redistribution, these sites cannot communicate with each other. The reason, provider routers, P routers, still don't have routes in the routing table. And even these routers are not capable to install all the prefixes of customer in routing table. So what is the solution here? Solution is label based forwarding. Label based forwarding, that is called MPLS, right? So here we have to now enable MPLS on this interface, this interface, this interface, and this interface. MPLS must be enabled. Then only these sites can communicate with each other. After enabling MPLS, what will happen? Routers will start forwarding traffic on the basis of label, right? So router 2, the provider router, is not going to compare destination IP address. It will not compare destination IP address. It will forward traffic on the basis of label, right? So maybe router 1 will have one label for this network. Let's say label is 20, right? So router 1 is going to add extra header with the actual IP packet. Actual IP packet is this one. 10.1 is the source, and 10.1.1.2 is the destination. Router 1 will find the exit interface is F0/0 and MPLS is enabled on F0/0. That means I need to add label here, right? It will add remote label and local label, right? And then it will forward to label is 20, then it will forward to router number 2. Router 2 is not going to check this IP header. Router 2 will check this MPLS header. In the MPLS header, it will see, okay, label is 20. Router in the LFIB table of R2, there will be one entry, right, for this label. To forward traffic to label number 20, I need to forward this to this interface, from this interface to R3. So all the provider routers, all 1,000 provider routers are going to forward traffic on the basis of label, right? So MPLS must be enabled in the service provider and router, then only communication will happen, right? So MP-BGP is, you can see, combination of multiple things: VRF, IGP, right? Then MP-BGP, VPN v4, and MPLS. Combination of these all the protocols. Okay, so same thing here you can see. Okay, so what I told you, MP-BGP supports multiple address family, right? Like IP4, IPv6, multicast, VPN, while traditional BGP only support IPv4 unicast routing. MP-BGP enables the exchange of routing information for other network type, other network type. Then next thing, what is next? Key features of MP-BGP. So you can read, like we already covered these all. This is nothing but the address family identifier, address family identifier, okay, or subsequent address family identifier, different type of routing protocol. Yeah, same thing. It's saying that MP-BGP is used for multiple types of address family, and these are the technical words, guys. Like address family identifier is called AFI in short, right? Or sequent address family identifier is called SAFI. Then second is route distinguisher. As I told you, route RD and RT. What is RD? RD is used to differentiate the route of different customers in the service provider network, right? So after adding RD value with route, what we call to that route? VPN v4 route. And to advertise VPN v4 route, we need MP-BGP, right? So here you can see RD differentiate overlapping IP address in the MPLS VPN, that the length is 64 bits, and RT control route propagation between VRF, right? So RD is going to tell which routes I should import and which route I should export in the VRF, in the VRF. Okay, for an example, R1, R2, and R3, PE1 and PE2. So when you will create the VRF, let's say here is customer A, customer A. So for customer A, I'm going to create VRF here. I will run command VRF definition A, and then I will define RD value 1:1. Then I will define RT value, route target value 10:10, like this. This will be the complete configuration of VRF. Then let's say this is 0/0 interface. So I will say interface F 0/0 and IP VRF forwarding A. So this command is going to put this interface in which VRF? In VRF A. And after that, we can configure IP address here, IP address, whatever IP address you want to configure. So router will create one separate routing table for VRF A, and in that routing table, it will store that network. Okay. So this RT value, route target value, there are two configuration of RT. On router number 1, I have to say RT export 10 ratio 10 ratio 10 10 ratio 10, right? Means whatever prefixes router 1 will advertise to other MP-BGP neighbor, it will add this RT value. And on R3, I have to say import 10 ratio 10, right, in VRF A. So whatever prefixes it will receive with RT value 10:10, it will import that in VRF A. And whatever prefixes R1 will export in VRF A, it will add this RT value. Or we can say both 10:10. Means you are importing as well as exporting 10:10 for VRF A, right? So these two terms are very important, and hope it is clear to you. RD and RT. RT stands for route target and RD stands for route distinguisher. RD is used to differentiate the route, and RT is used to import or export the route in VRF, right? Like guys, for an example, I have one switch, and this is the trunk link. And you know, trunk link can carry traffic of multiple VLAN, even all the VLAN. So if switch is receiving any traffic on the trunk link, what switch will check? Switch will check tag value. Then only with the help of tag value, only switch can understand this traffic belongs to which VLAN, right? So let's say this interface belongs to VLAN number 10, and this interface belongs to VLAN number 20. So if tag value is 10, that means switch will forward it from this interface. If tag value is 20, that means switch will forward it from this interface, correct? So this way, if it is a broadcast message, like here is any another switch which is forwarding a broadcast message, right, on the trunk link. So if tag value is 10, that means this traffic belongs to VLAN 10. It will forward it from the interface which is member of VLAN 10. In the same way, we are using RT here, route target value, used to import or export the prefixes in VRF. Then Yeah, definitely. I will share the recording. Actually, it is already available on the YouTube. This session is live on YouTube, right? So you can watch the video later as well. So, guys, sometime I'm not able to answer your question because it is not possible to answer each and every questions. So that's why I'm saying if you have any question, please write short question in the comment section so that it will be easy here for me to read and respond. Then the next thing is third thing is VPNs and MPLS support. So MP-BGP enable VPN by exchanging VPN IPv4 or IPv6 routes between provider is P routers in the MPLS network. Then multicasting. These are not for you now, but keep in mind that MP-BGP supports multicasting as well. For multicasting also we can use it. And guys, if you know need a detailed configuration video, like where I should configure everything from the scratch, step by step, then let me know in the comment section. Just say yes, please make one configuration video. Or if you need a live session like this webinar, then also you can request in the comment section. Definitely we'll try to arrange one more webinar for the configuration only, where we'll see the step by step configuration. In future, I am planning many more webinar for the advanced topics like the SD-WAN topics or the SD access, ACI, Palo Alto firewall, Checkpoint firewall, 14.8 firewall. So if you are new on the platform, please subscribe this channel and click on bell icon so that whenever we will be uploading new post, you will get notification, right? And if you want to be the best network engineer in 2025, right, which is coming soon, please following all the videos and every day try to measure the improvement in your skills. Every day try to learn new things, new topics, at least one topics. Still I am also learning one, at least one new topic every day. Until and unless I will not learn anything, I cannot sleep, right? So every day try to learn one topic, either it is a small topic or that depends on your skills, right? Or it can be advanced topic. But every day if you will be updating your skills, right, then you can see the exponential growth in your professional life. And on this platform, on PM networking platform, we are always updating the content. We are always posting the advanced concepts, sometimes definitely basic concepts as well, because basic is the foundation, right? So that's all. Now see the next. A service provider uses MP-BGP to connect multiple customer sites securely via an MPLS backbone. Yes, I already shown you this, right? So where we are using MP-BGP in the service provider network, in the service provider network, in the in the service provider network, we are using MP-BGP. Customer is and P router and C router. These two types of routers are very important for MP-BGP. And third type of routers are P routers. So these three types of routers are there to understand the complete MP-BGP. One is P router, provider router, C router, customer is router, and P router, provider is router. After this, guys, you can go for the like the VPN also, L3 VPN or the traffic engineering. These are the advanced topics. Someone is asking here. Yeah, you can go for the traffic engineering if MPLS is clear to you. I have watched your all playlist, MPLS playlist on YouTube. Great. Oh, if you have completed the MPLS playlist, I think there are 30 to 40 videos, right? That means you have covered all about the MPLS, right? You know the L2 VPN, L3 VPN configuration with multiple types of scenarios, real time scenarios. Then for the internal connectivity, see router connect PE routers using a standard dotting protocol called OSPF, EAGRP, or BGP. Between P to C, you can configure any protocol. The PE routers assign an RT to each customer VRF to avoid IP address conflict. Got it? To differentiate the subnet, we are using RD value, and service providers are going to assign this to the VRF, each and every VRF. After that, P to P via MPLS, BGP P to MP-BGP exchange VPN v4 routes between P routers, between multiple PE routers. MP-BGP is used to exchange VPN v4 routes. And what is VPN v4 routes? RD plus IP v4 route is called VPN v4 route. Then RT determine which routes are imported and exported into a VRF. That is called RT value. Anything else is there? Yeah, many things. Real-time use case. Any company with multiple global branches uses MP-BGP in its MPLS based WAN for the following: for connectivity, for connecting multiple branch offices to data center securely, or connecting multiple headquarters, connecting multiple sites to the headquarter or to the data center, using IPv4 and IPv6 across different regions, supporting multicast applications like video conferencing. Like, the companies called Netflix. These companies are definitely using multicast technology with the help of MP-BGP. So, like, let's say if you are going to watch any movie, so your device is going to join that multicast group, and on that particular multicast group, Netflix server is transmitting the movie. So this is how you are able to watch, right? So that's why subscription is required. To join that multicast group, you need to pay some amount. You have to purchase the membership. Isolating customer traffic in multi-tenant environment. Very good. That's fine. Then here is the configuration. You can see same configuration here. I also the team has mentioned, right? And after that, configuration of VRF. This is how you can configure the VRF. That's it. Okay. So guys, this is all about MP-BGP, and hope it is clear. If any question, if you have any question, please ask in the comment section. If you need any webinar on any other topic, please let us know in the comment section. You need webinar on which topic? Yes, also need configuration MP-BGP. Okay, noted. So we'll be uploading one detailed configuration video for MP-BGP. Okay, Arun, note it. Right. Anything else, guys? Any question, query, concern, anything? Let me know. Let's say between P to PE, R1, R1 and R2. Two sides, A, B, VRF A, VRF B. Here also VRF A and VRF B. Guys, between the routers, we can use sometime multiple link also. Why I am talking about this scenario? Because sometimes interview is asking this types of question in interview. So let's suppose for VRF A, you need a dedicated link here. You can use a dedicated link for VRF A and for VRF B. So this is also the scenario. Or the another scenario, between router 1 and router 2, I can have one link, and then we can create sub interface. Let's say this is 0/0, f0/0, this is f0/2. Done. And here we can create two virtual interface, 1, 2. One is, let's say, f0/0.1 and f0/0.2. f0/0.1, f0/0.2. Right? We can create sub interface also like this. So this will also work, this will also work. Both are correct scenario. Or we can have a single link also between R1 and R2. So in most of the scenario, we'll configure this one. Doesn't matter between P to P how many routers are there, how many links are there. We need reachability between the loopback to loopback. That's it. That is our requirement. Apart from this, guys, one interview preparation series is going on the channel. Right? If you are not watching that, you can check those videos as well. Right? Where I am talking about the scenario based interview questions. Okay, and today also I have one question for you. So if everything is clear, thank you. Okay, thank you so much. Welcome, guys, welcome everyone. Last, I'm going to ask you one question here. Question is, R1, R2 and R3, this is service provider network, SP, let's say Airtel or Tata Communication, right? And it is connecting to customer A, customer B, customer A, customer B, side 1, side 2, side 1, side 2. Here we have configured IGP protocol as well as MP-BGP protocol. Here I have configured IGP protocol, IGP, IGP. Here also IGP, IGP. But after implementation, everything, we have verified the routes. So routes are also there in the routing table of R1, R3, and side 1 have prefixes of side 2. Here also, here also, here also, and here also. But the issue is, customer A side 1 and side 2 are able to communicate, but customer B side 1 and side 2 are not able to communicate with each other. So try to find the answer. What can be the possible answer? This is an interview question. Recently, one of my paid student received this question in interview. So just try to find the answer. And this video is available on the YouTube. Please share your answer in the comment section of this video on YouTube channel. I will check your answer, and if you guys will not answer properly, then definitely I will record one video on it for the possible answer, right? And maybe interviewer can ask you this question to you also in the interview, right? So don't ignore it. Whenever you are able to find the interview questions from your domain, if you are a software engineer and there are some question on maybe Facebook or YouTube, anywhere, don't matter, on any platform, try to answer that. If you will start participating in question and answering, your skills will start improving, right? Like this way you can boost your technical skill. If you are network engineer, try to answer each and every questions everywhere, doesn't matter the questions is available on whom platform, it is PM networking or any other platform. On any platform, if the question is in front of you, if you are able to read the question, try to find the answer, right? When you will try to find the answer, you will get many new topics, new many concept, and then you are going to search it on the Google, and this way you can improve your skill. Okay, so in the scenario based network engineer series, I am posting one question every day, one scenario every day. Now I am covering the basic questions only from the subnetting and the VLAN, but later I am going to upload some advanced questions also there from the BGP, MP-BGP, MPLS, the firewall. Okay, for those. And guys, on the YouTube channel, which is the main platform of PM networking, we are done with the basic. I have already covered all the basic topics. I have covered all the topics of CCNP, CCIE, ESA firewall. Now, Palo Alto firewall is going on. So, what is your next requirement? Tell me that also. Like, which series I need to start? SD-WAN, automation, another firewall, checkpoint 14.8, cloud. So, if you are the regular follower of PM networking, regular subscribers of PM networking, if you are watching videos on PM networking every day, many of subscribers are already known for us. We know, right? Because every day we are able to see those comments, right? So if you are the regular subscriber, tell us on which series you want videos after completion of Palo Alto series. Okay, that's all for today, guys. Hope this webinar was helpful for you. You have learned something from this webinar. If yes, then please type yes in the chat once. This is the last request. If the webinar was helpful for you, just type yes in the chat in the comment section. Someone is raising the hand. See, brother, you are not allowed to speak. The reason is I don't have a speaker. I have only mic. I can only speak and I can see your chat. Yes, yes, yes. So many people are saying yes here also and on the social media platform also. So thank you so much, guys. The webinar is helpful for you. Thank you so much for joining. Thank you so much for following the PM networking. Thank you so much for continuous support. Every time your likes, comments are motivating me to make more videos. We'll meet soon in the next video, right, on any other important topics. That till then, stay safe. Bye bye. That's all for today.